All right, Aubrey and Carter, this is variation 2-8. This should be way easier than what we've been doing. There are, I say 4. I don't know if they're going to use all 4, but I say 4 types of variation, okay? So direct variation, inverse variation, joint variation, and then there's combined. So here is how this works. Okay, put this up at the top. This is going to be your cheat sheet. Direct variation, inverse variation, joint variation, and I'm going to say combined variation. I don't know if they will use combined, but I'm going to put it on here just in case. Okay, so there's 4 of them. Okay, here is how direct variation works. It's talking about how it relates variables. Okay, variation, how they are varying. Direct variation is relating two variables. We'll call them x and y. And direct variation is y equals k times x, where k is a constant. Okay, so for example, like y equals 2x, or y equals negative 3/4 x, something of that nature, right? That is a direct variation. If you graph a direct variation, what will he look like?
Straight line.
He's a linear. He is a straight line, right? Y equals something x, that's a linear function, okay? So direct variation, he will look like that, okay? Inverse, what? What?
We always go like horizontal or vertical, like.
What you
He'll, like as the number gets bigger, he'll go like more straight.
Yeah. Okay.
Yeah? Yeah. Like if I were to graph y equals 2x, that would be like 2x plus 0. So I would start at 0 and I would go f2 over 1.
Yeah.
And it would look like that.
It'll always be that.
Yeah. Now the numbers might be icky. Like it might be like 3.14x, right?
Okay.
So for example, okay, another direct variation. I'm going to like hint you in on, I think maybe this is a homework assignment. When you're talking about area, no, let's talk about circumference of a circle. Circumference is 2 pi r. That is a direct variation. True? But k, what would k be in that case?
Pi.
You're close.
2 pi.
2 pi. 2 pi is the constant, the number that's in front of my variable, right? Okay, makes sense? So circumference equals 2 pi r, that's a direct variation as well, okay? All right, inverse looks like y equals k over x. That's inverse variation. They sometimes will call this, also write this down, indirect. Okay, they have direct and indirect. Indirect and inverse, they sometimes use those interchangeably. Those mean the same thing. But basically, this is an inverse relationship. If you go to graph this guy, do you know what he looks like?
Parabola.
He's one of these guys, the boomerangies, right? Something over x, like y equals 3 over x, or something like that, right? That would be in a scenario where we have inverse variation. Okay?
Is K always a constant? Or just in the first?
K is always a constant. Yeah, K is always a number. Yes. So I'll say K is a constant. Okay, now your constant might be pi, right? Like in this example. Pi is just a number, right? Or it might be E. Okay, E is a constant as well. But there's that. Okay, joint variation has 3 variables. So for example, y equals kxz. And the reason why it's joint variation is because x and z have to join together to create what y is, right? So this might be like, I don't know, volume is length times width times height. There are 3 variables that are joining together to make volume. So in that case, there's 4 variables total. So yeah, 3 plus variables is what you would have for joint. Yes, good thought. Let's just write it like that, okay? So those 3 are joining together to create what the output value is, which is volume, okay? So that would be an example of joint variation, okay? In this case, what's my constant? For volume equals length with height. What's K?
0, 1.
1. It's the number in front of length with height, which is 1, right? So K in that case is 1. It's the constant that's in front of my variables. Got it? Okay, and then combined variation combines
Does that have a specific?
direct and indirect. So for example, this will have 3 plus variables also. So here's an example, y equals kx over z. Y equals kx over z.
Do we know what the graph always looks like on joint?
Oh, joint will be a 3-dimensional graph. So don't worry about the graph for joint, and don't worry about the graph for combined because you have 3 variables. So don't worry about the graphs for those, okay? Combined has 3 plus variables, so y, x, and z. This would be like, what is it, like distance equals rate times time. That would be joint. Distance equals rate times time. That's a joint variation, right? That's another application of joint variation. What about temperature over pressure? That is temperature over pressure. Is that volume? Volume equals temperature over pressure.
We're working with force right now.
Force. Force is temperature over pressure. No.
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 That's what we're working on in physics right now, so I can't tell you. Force equals mass times acceleration.
Force equals mass times acceleration. That's a joint. What?
Force equals
The universe of
What
gravity.
is temperature over
Yeah,
pressure?
because gravity is a constant. Okay. I'm gonna write this equation for you.
What?
gravity constant.
Ready?
What?
This is our one right now.
Any over distance squared.
What'd you say? Distance squared. This is a constant. I'd rather do this. It doesn't change.
Yeah, so that's your
It's
K.
7.67 times 10 to the
20.
negative 11th.
Okay. Yeah. So that would be a combined variation, but your K would be G. Yeah. I don't remember. What's temperature over pressure though? Something is temperature over pressure.
What does temperature divided by pressure equal?
Is it volume?
No, that's more
What the
Karen, right?
heck
Wait,
is it?
Are you talking about Charles law? Give me 1 second.
I don't remember. I'm gonna erase it. What?
Charles law is like volume over temperature.
I don't know.
I don't remember. But combined variation, something over something, whatever. So there's that. Okay. Now the verbiage or the wording that will be used is that, like for this example, they will use the words y varies directly with x and inversely with z. Okay, so when you have a combined variation, they won't say combined variation. They will say it's directly related to x and inversely related to z. That's an example of combined where you have both of them happening at the same time. So when they say that, that's what this equation produces. Okay, y equals kx over z. K is your constant. K is always in the top. You could also say, if you guys are used to writing it in like physics, y equals kx over z. You could throw the k out in front. So your K is always either in the top or on the front, right, of your combined variation. All right, but that's the verbiage that they will use for combined variation. All right, let's get rolling.
Hang on, I gotta write that. Y is equal to K over Z. Oh, KX over Z. Okay.
Okay, so for graphing purposes, they said that this is d equals 60t. That's an equation for direct variation.
Okay.
So that is an example of a direct variation where we're comparing distance traveled versus time. Okay, that's a direct variation. This guy over here is the time in relationship to the rate, right? So the time that it takes is the distance divided by the rate that I'm going, right? So that is an inverse relationship. It's doing that boomerangy thing. But why don't they have the bottom boomerang? Why do they only have like the top boomerang?
You can't have a negative time.
You can't have a negative time or a negative rate, right? Like I can't go backwards and have a negative 30 miles an hour. Like that doesn't work, right? So that's why we only look at this top corner. But this is still an inverse or indirect.
You can go a negative if you're going back.
I think they represent it equationally as a negative, but yeah. Or like a negative velocity is falling toward the earth, whatever. Okay, let's do some examples. All right, I'm gonna skip this box because that's exactly what I said to you already. Example 1, write the variation model using K as a constant of variation. All right, the amount of medicine A prescribed by a physician varies directly. So let's underline your variable, circle whether it's what the variation is. A varies directly
A equals W.
as the weight of a patient. Okay?
Okay.
So A equals
W. K. W.
KW, right? Where your constant, we don't know what the constant of variation is, so we just put K in there. Okay? And the K is probably going to depend on what medication we have, right? So I take the dosage of the medication times the weight of the person to get the amount that I'm going to prescribe. Does that make sense? And K is whatever the dosage is, right? Okay? So that is the variation model. And then we could use values to go in and solve for K and things like that, right? But they're not going to have us do that yet, okay? B, it says the frequency, which is F, is inversely proportionate to the length, okay? So F is, the word is equal to, so F equals, since it's inverse, K goes on top, and what's my,
L.
L goes on bottom? This is my variation model. Okay, they're just having you write out like what the skeleton of the model is. Got it? Not solving for anything yet.
Are we gonna do this on our homework?
I think so. I think that's what like the first three of them are. Okay. Part C, the variable y varies directly as the square of x. Okay, and inversely as the square root of z. So y is my variable, and we have direct and inverse. So this is one of those combined ones.
The square root of x.
So I want k on the top and the square of x. What's the square of x look like?
X squared.
X squared, and then the square root of z goes on the
Bottom.
bottom. So that's a little bit more intricate because they have the square and the square root stuff. So make sure you insert those where they need to be. But that's the variation model. Got it? That was a combined variation. What? Okay. Did you hear me? Did you send a message
There's
back?
4 girls in here that I sent emails to for
Oh,
our
yeah.
social
Yeah.
media team day
I
that
got
we're
it.
doing. I think we can take more than 6, so if there's other ones that you think about,
Okay,
let me know.
sure.
We're gonna go over Canva and I think Adobe. Next year, some of you juniors in here will help out. Libby Mack was pretty much doing everything this year for every
Mhm.
event. So in years
I think they had two the year
years
before though.
past, we've had
Mhm.
like a cross-country person that does those cross-country posts, a couple volleyball ones that do volleyball and football.
Yeah.
That just divides it up.
Right. Right. Yeah. Very
And
cool.
Canva, I get a pro account. Do you have a Canva account?
Which is
Mhm.
brown.
Ours is pro, so
Yeah.
it's got like AI built in with it.
Yeah.
So now
It's
you can,
cool,
you can just say like, hey, I want to create something for blah, blah, blah.
and it will
And
like
the AI just
do it.
it
It's
just
awesome.
puts the
Yeah.
whole thing together.
Yeah.
And I don't think the students have the pro version.
No,
So we
but
might
there's
just-
something that you can do for like the
we can
students
just
to
share our
get it.
logins
You
with
can
them.
build a class.
Yeah,
What's that?
build a class.
Yeah, because we have Mrs. Brown.
Because there's a way of getting them to do that without having to like share your login. Like they can do it on their own account, but I just don't know
Last
how.
year when they went to-
Kristen, was it Kristen at, because I went to the Canva one at the TLC conference in Adams Central, and no, it wasn't. It was Lauracia. She was the one that did that one, and she said that there's a way of getting your students the pro access as well.
I may have you and Beth go that day or
Okay, sure,
anybody.
that'd be fine.
I may go too. We'll see.
That would be cool. I would love to learn more about Photoshop because you guys can do that better than I
Mrs.
can.
Brown's.
Sorry, I got you into that. He said, "Who should go?" And I said, "These are my Photoshop people."
We went last year too.
What?
Who's
Yeah,
not going
last
to
year.
that then?
It's us four.
I think. Anyway, so I suckered you into that. Sorry. If anybody else wants to go, they can. I'll recommend you as well.
A junior.
You don't count.
I
What?
take a junior. Or a sophomore.
A sophomore? I think they recommended. Who was it? Mrs. Bokelman said Macy Olson.
she's
She's a
going.
freshman.
Yeah.
But they said Ava Lee would be okay. Sure. Yeah, that'd be fine.
This one goes off screen.
Yeah. I just didn't know how many we could.
The
Whatever.
31st of January.
Okay. Anyway. All right. Moving on. So, people are watching this video. Sorry. Example 2. Write a variation model using k as a constant of variation. So same thing. Joint variation. Y varies jointly as t and the cube root of u. Joint variation was when you have 3 plus variables. So y is my variable equals
K.
k
T.
t
Cubic of U.
cubic root of u. There he is. Where k is my constant. So T times the cube root of U times K gives you Y. That's my stuff. Okay, B, the gravitational force of attraction between two planets. What shall we call the gravitational force of attraction between two planets? We have to give it a variable. G, capital G?
Yeah.
The gravitational force varies jointly as the product of their masses.
So plus.
Okay, as the product, what's product mean? Multiplying their masses together.
Mass one, mass two.
Mass 1, mass 2.
Oh no.
Mass 1, mass 2.
Divided by
And
D squared.
inversely as the square
D
of
squared.
the distance between them.
Wait,
Why?
why?
Physics.
Why physics?
We're
Just
literally.
multiply
D
the
squared?
Hear me out.
This is
Multiply the
literally
G
the
over and
equation
you'll
I
get
just
force.
wrote
If
on
you
there.
multiply G to that, you get force. That's all
Don't
we're talking
take
about.
Okay, but what are we missing?
Force.
Okay.
K.
To the top.
Sure, to the top or to the side. There you go.
So we're supposed that's wrong.
No. G needs to K
Yeah,
needs
G
to be G and G needs to be F.
No,
Yes. For physics.
because you could switch the two around.
To find
Like to
G,
solve
you
for
have
G,
find-
to solve for G, you could switch the equation around and like K would technically be 1 over F, right? 1 over the force. So if force is equal to G times mass 1, mass 2 over D squared, I am setting up this equation so I'm solving for G. So G would be equal to 1 over the force times mass 1, mass 2 over D squared. So technically, K would be 1 over F, but they just want this thing right here. So they just have it set up so that we're solving for G, not for force.
No,
Whatever.
G.
But we already know G.
It's 6.67 times 10 to
We're
the
just using
Not-
24.
We're just using
That's-
the wrong letters.
Isn't that for Earth though?
Yeah.
This
That's
is
for
for
everything. That's
this is
everything.
for anything.
Two
No,
planets.
this is for
This
two
is
different
other
planets. Any two things on Earth will have that gravitational force, the 6.67. But we're talking about two different planets, which will have different gravitational force, and we are finding that.
No, our 6.67 is for
It's for everything. It's the
Oh, it is?
It's the universal constant.
I don't know. I don't know.
Right.
Because small
I
G
don't
is
know.
only
Okay, let's
for-
solve something.
Because small G is only for the Earth.
Reese,
Big G is for the
do they look
universe.
similar?
Okay.
Yeah.
I don't know. That's just what they say.
Kinda.
Without the
mustache, you'd be
Literally.
All right, let's do example 3. We're solving something. Here we go. We'll read the first part, get our equation ready to go, and then we'll answer the questions ABC. The amount of an allergy medicine that a physician prescribes to a child varies directly as the weight of the child. Okay, so what do we call the amount of medicine? A, sure, the amount is equal to directly with the weight of the child.
K times W.
K times the weight, okay? It says clinical research suggests that 13.5 milligrams should be given to a 30-pound child. What is 13.5?
K.
No.
No. A. It's A.
13.5 should be given to A, or given to the child. That is 30 pounds. So we are solving for K. And K is the constant, but K in this scenario represents kind of the dosage, right? K would kind of be the dosage. So what would the dosage be? If I take, am I
0.45.
trying to find K? I would divide 30 over.
0.45.
13.5 divided by 30, K is what?
0.45.
0.45. So it's 0.45 whatever milligrams per pound, right?
22.
That's what K is representing in this case. So my actual equation is A equals 0.45 times the weight. It's 0.45 per pound, and now we can figure out for a 50-pound child or a 60-pound child, what is the deal, right? So A is going to be 0.45 times 50, and that is something.
22.5.
So they should get 22.5 milligrams. Okay, if it's a 60-pound child, 0.45 times 60, 27 milligrams. Perfect. Okay. So step 1, maybe put that over here to the side. When you are solving for a story problem, find your K, which is your constant. So you've written the equation. They're going to give you numbers. Solve for K, and then use that to solve something else, right? So you need to find out what the value of K is first and foremost when you're given actual numbers. Okay. Part C says a nurse wants to double check the dosage on a doctor's order of 18 milligrams. For a child of what weight is the dosage appropriate?
40 pounds.
So now we have 18 as the A. 0.45 goes here. We want to know the weight. So
40.
divide by 0.45. And that is what?
40.
40 pounds? Okay, so she's figured out that should be for a 40-pound child. I check in my chart, is the child 40 pounds? Yep, so we're good to go. Make sense? This is like how they double check things. Okay? Yeah. Okay, last one. Example 4 on the back side. The loudness of sound measured in decibels, which is lowercase d, capital B. What shall we use to represent loudness?
L.
L, capital L, varies inversely as the square of the distance.
D squared on the bottom.
D squared on the bottom. And the source of the sound, as the square of the distance between the listener and the source of the sound. Okay? Is that my equation?
K on the top.
K on the top. If the loudness is 17.92,
So
loudness is 17.92, and the distance of 10 feet from a stereo speaker,
So 10 squared.
10 squared goes on the bottom.
So 100.
So 100 basically on the bottom. Okay. It says, what is the decibel level 20 feet from the speaker? Hold up. Don't worry about the 20 yet. We got to find K first, right? We got to find the constant first, okay? So this is 100, but to get the K, I'm going to multiply by 100 to the other side. So what's our constant? 1792, okay? Now I'm going to rewrite this equation right here. And now we know what our constant is that we are going to use for the next piece. It says, what is the decibel level? In other words, what is the loudness if I'm 20 feet away instead of 10 feet away, okay? I know the loudness at 10 feet away is 17.92, right? So I know it should be louder than that, but it's not necessarily going to be double, true? Yeah? Okay, so distance is 20. 20 squared is 400. Take 1792 divided by 400. What do you get?
Can you zoom out just a little bit?
Oh, yeah.
4.48. 4.48.
Is that true?
Well, you're farther away.
Oh yeah. I said it should be louder. It shouldn't be louder because you're further away. I'm sorry. Yes. So 4.48 dB. That is true. That makes sense. Does that make sense?
Yeah.
Yes. So they will give you scenarios. Find your K first. Use that to find something else. It's not too bad. This is like a huge step down from what we've been doing, right? Yeah? Like way easier. Okay. All right. Goodbye, people watching this.